This video is starting with question number 25 of the Unit 9 Circles review. Here's number 25. It starts off with the sentence, an extra large pizza with a diameter of 24 inches is divided into 16 equal slices. Well, when I see diameter, class, I want to stop and go ahead and write down the radius, because I know I'm going to be using the radius in my equations and not the diameter. So if the diameter is 24, the radius is half of that, which is 12 inches. All right. What is the arc length of one slice? Well, I know we have 16 equal slices, so I'm going to have to figure out the circumference of the entire circle first before I can figure out the length of the arc of one slice. So we're going to go ahead and find the circumference. Circumference is 2 pi r, which is going to be 2 pi 12. We can combine the 2 multiplied times the 12, and that's 24 pi. So the circumference is 24 pi inches, and now we'll go ahead and use that in our final answer. Our final answer for the arc length of one slice is 24 pi. That's the whole circumference times the fraction that we want. Well, we've got 16 equal slices. We want one slice. So that's 1 over 16. I'm going to show you, I'm going to put that in my calculator. I won't do this very often, but let's put this in real quick. I want to make sure you guys are putting this in correctly. So 24 pi times parentheses 1 divided by 16 close parentheses equal. The answer is 4.71. We can round that to 4.7. So 4.7 inches. Circumference is measured in just regular units or inches. All right. Next question, what is the area of one slice? Well, area, we have to find the area of the whole pizza first. So let's find the area of the whole pizza. Area is going to be pi r squared, which is pi 12 squared. 12 squared is 144. So the area is 144 pi inches squared. Now let's go ahead and find the area of one slice. Same procedure as 25. We take the total area of the pizza and we multiply it times the fraction that we want, which is 1/16, or one piece out of 16. Put that in our calculator the same way. We're going to get approximately 28.3 inches squared. Oh, I forgot. The instructions say circle your final answer. There we go. Right, number 27. If you eat 7 pieces, how many square inches did you eat? I cautioned you in class that if you take one piece area, the area of one piece, and you multiply it by 7, you might get some rounding errors. So I suggest on this one, you go through the same process. Take the whole area of the pizza and multiply it by with the fraction that we're going to eat. We're going to eat 7 pieces out of 16 pieces. And that ends up being approximately 197.9 inches squared. All right, question number 28, a speedometer problem. The speedometer above is designed using a semicircle, so we know this is exactly 180 degrees. The length of the needle is 8 centimeters. How far will the end of the needle travel? Now that's telling us, class, if we look at the end of the needle, if we're going right here, that's an arc. That's part of a circumference. There's nothing about the area here. We're talking about an arc length. How far will the end of the needle travel if your speed changes from 35 to 65? Now the trick on these kind of problems is that we're dealing with a semicircle. So we want to picture this as an entire circle. That's how I find the easiest way to solve it is. If we know that traveling from here to here we went 100 miles per hour, then we know when we go back all the way to the other side, the whole circle is going to be 200 miles per hour. So let's treat this as a whole circle. Okay, before we actually solve that, we're going to need to figure out the circumference of this circle. So the circumference of the whole circle is going to be 2 pi r, which is 2 pi. We know the radius is 8. So we know the circumference is going to be 16 pi centimeters. And now let's go ahead and find how far we traveled here. So we're going to take our total circumference of 16 pi. We got to figure out what fraction we are traveling. Well, now we know the whole circle would be 200 miles per hour. That's how many miles per hour the whole thing would be. And how many miles per hour are we traveling? Well, we're going 10, 20, 30, 35. We're changing from 30 to 65. So we're actually moving 35 miles per hour. In our calculator, that's going to be approximately 8.8 centimeters. Oh, I put centimeters here. Yeah, that's correct. On my entry key I put inches, but in this case we know we are dealing with centimeters. Alright, let's continue. Question number 29. If segment SR is 13 centimeters long, I'm going to label that now. This is 13 centimeters. What is the diameter of circle C? Well, I already can see, class, this is a triangle inscribed in a circle. The hypotenuse clearly goes through the center of the circle. That makes it a diameter. That means this is a right angle. If that's a right angle, we can find the rest of the degrees of this by subtracting 90 and 45 from 180. That makes it a 45, 45, 90 triangle, which is an isosceles triangle. And that means we know these two legs are congruent. So this side is also 13 centimeters. Well, we got a triangle. We know the lengths of the two legs. There's actually two ways to solve this. Way number one is using Pythagorean theorem. A squared plus b squared. C squared is our unknown. That's the diameter or the hypotenuse. So 13 squared plus 13 squared equals c squared. 169 plus 169 equals c squared. That's 338 equals c squared. And that means c is going to be the square root of 338, which is approximately, let's check this, the square root of, oops, clear this, square root of 338 equals 18.38, so 18.4, approximately 18.4. Our unit of measure is centimeters. There's one way to solve it. Well, the other way is this. This is a 45, 45, 90 triangle. It's a special triangle. We know that a special triangle, 45, 45, 90, if the leg is x, then the other leg is x, and then the hypotenuse is x times the square root of 2. So you could also have solved this by just writing 13 times the square root of 2. Let's check that out. 13 times the square root of 2. I'll close the parentheses there. And the same answer, 18.4. So two ways, 18.4 centimeters. Two ways to solve this particular problem. Question number 30. The beam from a lighthouse reaches a distance of 14 miles. I know, class, when that says 14 miles, a distance of 14 miles, I know this measure right here is 14 miles because that's how far the light is traveling. And spreads to an angle of 47 degrees. That means these degrees are 47 degrees. That's our central angle. What is the area? The area covered by the lighthouse beam. Write your final answer in a complete sentence. Alright, well, I'm going to find, this is a sector area. So the first step is to find the total area. The total area, if this were a whole circle, would be pi r squared, which would be pi times 14 squared, which would be 196 pi. That'd be miles squared. Alright, now to find our sector area, we just take the total area, 196 pi, and we multiply it times the fraction of the area that we want. Well, they gave us the degrees of our sector is 47. Total degrees of a circle are 360. So let's put that in our calculator. Our approximate answer will be 80.4 miles squared, because this is sector area. So let's write our final answer here. The area covered by the beam is, I'll put around, is around, that's like approximately, is around 80.4 miles squared. Now, sometimes you wonder, how do I start my sentence? It's so easy. Just go right back to the question. The area covered by the lighthouse beam. I could have written, the area covered by the lighthouse beam is around. I just cut out lighthouse because I think it's clear we're talking about a lighthouse. The area covered by the beam is around 80.4 miles squared. That takes care of the first column of this page.